All right, let's dive into one of the biggest, most frustrating paradoxes in all of technology. Why the software that runs our entire world, from our phones to our cars to literally everything, is and always will be fundamentally imperfect. You know the feeling, right? You're deep into a project. Maybe you're about to beat the final boss in a game, and then, poof, the app just vanishes. It crashes. We've all been there, staring at the screen, wondering how, with all this incredible tech, do these glitches still happen? Well, that frustration feeds into this huge myth that a lot of us believe, especially when we're new to tech. It's the idea that with enough skill, enough time, enough testing, someone out there can actually write perfect 100% bug-free code. Today, we're going to totally pull that myth apart. And if you need any proof, just look at the titans of the industry. Companies like Google, Microsoft, Apple, we're talking in billions of dollars, armies of the smartest engineers on the planet. They all ship products with known bugs. This isn't because they're bad at their jobs. It's just a fundamental reality of building software. So, what's the number one reason for this? Well, it all starts with what I call the complexity engine. It's this idea that the very nature of software, how it's built, makes bugs a mathematical certainty. So here's the core concept. Software isn't like a brick. It's more like a web. And every time you add a new feature, you're not just adding one new piece. Oh no, you're adding countless new connections and potential interactions with everything that's already there. The complexity doesn't just add up, it multiplies, it explodes. And this chart really shows you what that explosion looks like. See? With just 2 little modules, you've only got a few connections to worry about. But by the time you hit 10 modules, which, by the way, is tiny for modern software, the number of ways they can interact is just astronomical. You literally cannot test them all. And this quote just nails it. Trying to test every one of those interactions is like trying to drive down every single street in every possible order in a massive city like London or Tokyo. Sure, you can check the main highways, the big roads, but you can never, ever cover every tiny side street and back alley. It's just mathematically impossible. All right, so the math is already working against us. But now let's layer on top of that the wonderfully messy, unpredictable reality of the human factor. I mean, it's the simplest truth in the world, right? Code doesn't just magically appear. People write it. And you know what? People get tired. We misunderstand things. We forget about that one weird edge case. Expecting thousands and thousands of lines of code to be perfect is like expecting a novelist to write an entire book without a single typo. It's just not going to happen. And this right here, this is where so many bugs are born. It's in that gap between our neat, tidy assumptions and the absolute chaos of the real world. A developer assumes, hey, people will put numbers in a phone number field, but of course someone's going to try to use emojis. We assume the network is always on, but then a user walks into a tunnel. These aren't bad assumptions, they're just incomplete. And let's be real for a second. If we were all perfect little coding robots, the entire amazing ecosystem of sites like Stack Overflow, the place that has saved every developer at least once, it just wouldn't need to exist. It's proof that programming is all about collaboration and solving problems together. And get this, even if you could somehow write perfect code, it wouldn't stay perfect. Software isn't a statue you carve and leave in a museum. It's a living thing in a world that's constantly changing. An OS update can break something that worked flawlessly yesterday. A service you depend on might just shut down. Your code never exists in a bubble. Okay, so if bugs are inevitable because of complexity and because we're human, what are we supposed to do? Just give up? No way. Instead, the entire industry has made a huge mindset shift from chasing perfection to building for resilience. And that's the natural question, isn't it? If you can't actually win the game and make something perfect, why even bother playing? It's a totally fair question, but it's aimed at the wrong target. Because here's the secret. The real goal of modern software development isn't to create something with 0 bugs. That's impossible. The real goal is to understand that bugs will happen and to build systems that can handle them without falling apart. It's all about managing risk and minimizing the impact. So how do the pros do it? Well, they've got a whole playbook. They use smarter automated testing. They have incredible monitoring tools to see exactly what's going on in real time. They design for something called graceful failure, which means one small error doesn't take down the entire system. And if a disaster does happen, they've got an escape hatch, like an automated rollback, to instantly go back to a version that worked. So maybe we need to completely redefine the word bug. It's not a failure, it's just a natural side effect of making something new and complicated. In fact, every single bug is an opportunity, it's a lesson. It's the system telling you how it really works, giving you a chance to make it even better. And that really brings us to the most important takeaway here. We are not chasing the impossible ghost of perfection. We're fighting for something much, much more valuable. Software that's reliable enough for you to count on, resilient enough to survive a hit, and that's always, always getting better. That's progress. So I'm going to leave you with this question to think about. Whether you write code for a living or you just use apps every day, think about a time a bug really made you stop and think. What did it show you? What's the most important lesson a simple software bug has ever taught you?